Very good morning. Today I am going to explain about how the four route traffic signal controlled by PLC. Yes, first there are four routes. In that four routes there are three lights we need to use. One is green color we have to use, then we have to use yellow color, then we have to use red color. So these three lights has to control the each route. So there are four routes: route 1, route 2, route 3 and route 4. So let us take example. If route 1 green light is on, then other three routes should be highlighted by red color. And next, once the green light is completed, then it has to shift to the yellow color, and afterwards red color. Like that, it has to continue all the four routes. And total our cycle time is 120 seconds. So here we need to use one timer, so that will count for total time from 120 seconds. And here we are using base time as our 0.1 second, so that overall preset time k is equal to 120 1200. So the same value what we have used here. So that is our one cycle time. And here first we have to start with our ladder logic in simple way. First is a one input. We have a two inputs. One is x0 and x1. This is a start button and this is a stop button. Only two inputs we need to use here. And afterwards one timer we need to use, that is t0, that will count time from 1200 seconds. Means it will count for 120 seconds, but its preset value is 1200. Then output. So coming to the output, total we have 12 outputs. So 3 output for route 1 and 3 output for route 2, 3 output for route 3 and route 4 have 3 output. So total we have 12 outputs. So Y14, Y1, Y2, like that we have till Y13. So these are our outputs. Yes, once we start this start button, we can use any input like physical input like push button or any signals we can use to start this. Once we start, and here it is normally closed because this is an emergency button, emergency stop. Once we start, it will start our M10. So M10 we can use it as it's a memory bit where it will use this memory to latch this, and it is continuously on. So the same output, this M10 we used here to start our next runs. So in the next runs we used M10 and we are here used T0. So T0 I used here to repeat the cycle. Once it is complete the 120 seconds, then it has to start once again. That's why I used here normally closed button to repeat this cycle. And afterwards I used one more memory bit, that is M1. And this M1 I used to start our timer cycle. Once the timer cycle starts, from it will count from 1 second to 120 seconds. In between that, so if it is, let us take an example of 10 seconds. If it is 10 seconds, that 10 seconds indicate that our green light should be on. Means here we have it is not only a one solution. Here we have some more solutions, like we can solve this problem by using some blocks, timer blocks. Even we can use some TP timer blocks, where we need to use a timer block for 1, 2, 3 and 4. That's a one way of solving this. But I used here, so I used only one timer. That one timer counts from 1 seconds to 120 seconds. In between that, I will compare that value by using arithmetic operations. And these arithmetic operations will give our output. See, let us take first. It is 0, greater than or 0. If the timer is greater than or equal to 0 to 25 seconds. If our timer count is 0 to 25 seconds, then this green light for route 1 should be on. Next, after 25, if it is 26 seconds, then from 26 seconds to 30, means only 5 seconds, it has to on for the yellow. So yellow light for route 1. And after 30 seconds, next for entire completion of cycle, it will on the red color. And next, similarly, it will go to the next line. So here, next it is 31, 32. The timer is keep on continuous. Once it is 30 to 55 seconds, that is a range, 30 to 55 seconds, it will give the signal for green for the next root. For second root, it will give the green color. And the next comparison, greater than equal to 55 seconds to 60 seconds, only 5 seconds, it will give the yellow color for second root. And after that, if these two are, we are using normally closed, means if anyone giving signal, red should not give the signal. So if no signal from these two, then it will shift to the red color. Yes, after that it will go to the third root. In the third root, again from 60 seconds to it is 85 seconds. 25 seconds is green for the third root. In the third root, it is green color. And after 85 seconds to the 90 seconds, means 5 seconds, it will on the yellow color. And after these two completion, the red will remains for red color. And similarly for the last one, in the last one, it is from 90 seconds to 115 seconds. After 115 to the 120 seconds, it is yellow and it is green. Afterwards, it is red. Means here we are using clearly. So in the first, if this is 1 and other two should be 0, 0. And the next, and this is 0, this is 0, this is 1. And here this is 0, this is 0, this is 1. This is 0, this is 0, this is 1. Means if one signal giving one root giving one signal, means other three should be red color. See here red color, here red color, here red color. But here only giving a green color. So next, similarly, if second root giving green color, means next this is red and this is red and this is red. Only this will give the output. That is 1. So like that, we have to use our timer to execute all the 4 roots. And it will control the green color, yellow color and red color. Yes, now we will execute the same program by using our GXWorks 3, because we are using Mitsubishi as a PLC, so that we need to use a GXWorks 3. So once we open the GXWorks 3, yes, I already created a program. And here first this is a start button and this is a stop button. This is a main cycle on latched M0 we used, and here M0 and T0 it's our time, and it is M1 our it's a one more memory bit to continue our cycle. And afterwards next M1 it is on, so I used it triggers the time and timer will starts counting from 1 to 120 seconds. While counting, we will compare by using our arithmetic operations to give some outputs like y14, y1, y2, like that. First, once we start this, we need to convert. And once we converted, next we have to go to the simulation. Yes, there is no error. It will directly take to the simulation. And yes, here we already created same program what I explained, the same program I created here. And once we give the input for this start button, yes, timer cycle, it's a latching on and it starts the timer and it will count between 1 to 25 seconds. 1 to 25 seconds, it will on the first root green light is on. After 25 to 30 seconds, next it will on the yellow color. It will compare the value greater than or equal. Yes, it will shift it to the yellow color. And root 2, 3 and 4, it is red color. Only in the root 1 it is. Yes. Now root 1, 2, it shifted to the root 2 and the timer is more than 30 seconds. Yes. Here root 2 green color and root 1 is become red. And root 3 is also red, root 4 is also red. And after reaches 55, it shifted to the yellow. Next, after 5 seconds, it will shift to the red and again turn to the root 3 cycle, green color. So root 3, green color till it reaches the 85 seconds. Once it reaches the 85 seconds, it will convert to the yellow color for 5 seconds. And root 2 is also become red. Root 1 is also become red. So now it will shift to the yellow color. Yes, yellow. After 5 seconds, it will turn to the red for the root 3. Yes, now root 4 will starts for the green color and other 3 is in the red color. Yes, for the 25 seconds. Once it reached the 115 seconds, next it will shift it to the yellow color. Root 4 yellow color. Yes, now yellow color. After 5 seconds, it will turn to the red and the cycle will repeat. Yes, see, the cycle is again repeats. Why it is repeats? We use the T0 as a normally closed to repeat the cycle. Once it reaches the 120 seconds, this T0 will become normally open. Once it is normally open, it will disconnect all the signals. It is become off. Once it is become off, there is no signal for T0. Again, it will connect and it will send the signal and it will start the cycle. So in this way, it will automatically repeat the cycle. So once our program is, everything is okay, now we need to transfer this. I will stop the simulation and I will go to the online where I need to write this PLC to the our hardware. I will select this, then execute, yes, yes to all. Okay. Yes, after writing our PLC program from our system to the hardware kit. So here this is what our PLC, Mitsubishi Electric. So it's a compact PLC. Here once we transferred, so then we need to reset this. So here there is a button, we need to reset this. So first we have to pull down. Then after once it's showing error and it will stop. Afterwards we have to push up this button so that it will start the P run, means program run. So our program is transferred to the PLC. So next this is an physical inputs and this is a physical outputs. So here we need to connect our PLC physical input to our hardware. This is a trainer kit, and the same way we need to connect our physical output to our here traffic signal. So first, yes, x0 and x1, we used two inputs, x0 and x1. So this x0 and x1, it's a start button and it's stop button. So we connected this start and stop button to our push button 1 and push button 2. Along with that, we connected to our hardware trainer kit. Here it is a start button and stop button. It is a x0 and it is x1. So this we connected through our inputs. So next, similarly, we need to connect our outputs. This is a root 1, root 2, root 3 and root 4. So here root 1 green color, yellow color, red color, green color, yellow color, red color, and the green color, yellow color, red, green, yellow and red. These are the 4 roots. Once this green color root 1 on, other 3 should be red color. So likewise, it has to transfer and complete 120 seconds. After that, again, it has to repeat the cycle. So first, we connected this green color for root 1 through this our physical output. Yes, once we start our by using start button, once we start, yes, by using your push button we can start, or by using this switch, or we can use the x0 switch. So once we start, this root 1 green color is on for 25 seconds and timer is also simultaneously on and it will count. And the timer value is between 0 to 25, green color is on, and baki 3 means other 3 are in the red color, 1, 2, 3. Next 5 seconds it will shift it to the yellow. Afterwards 5 seconds, yes, automatically it will shift it to the red color and transfer to the root 2. And in the root 2, green color is on and it is counted timer from 30 to 55 seconds. Means again 25 seconds this green color is on to allow the vehicle to pass. Afterwards it will shift to the yellow color, then transfer to the red color. Yes, now it is yellow color only for the 5 seconds. After that it will turn to the red and simultaneously it will start the third root green color. And again this third root green color is stayed for 25 seconds means nearly up to 60 to 85 seconds. From 60 to 85 seconds the timer counting, so that will trigger the output of third root green color. After this 25 seconds it will shift it to the 5 seconds for yellow color, then it will shift to the red. Once it is, yes, green color is on for the fourth root, but root 1, root 2, root 3 it is in the red color. There is no movement of the vehicle, it is red color. And in the fourth green color it is stay for 25 seconds. The timer is counting from 90 to 115 seconds. Once it is reached the 115 seconds, then it will transfer to the yellow color. Yes, and after 5 seconds red, and simultaneously it will repeat the cycle. Yes, see, simultaneously it will repeat the cycle. Again it starts from the root 1 red, then yellow, then red, like that root 1, root 2, root 3, root 4, it will continuous. So likewise we can execute our PLC program on the trainer kit, how we can control the 4 root traffic signal. Thank you.